For better cornering in our EV racing car, we need all systems to work together. The chassis must be stiff but adjustable, so the car stays stable through turn. We need high grip tire and real-time pressure monitoring to keep traction strong. Steering must be sharp and give the driver good feedback. The powertrain has to manage torque at each wheel to help the car rotate better in corner, and braking must stay smooth and balanced. Aerodynamic should give us enough downforce without slowing us down. The brakes must stay cool and strong enough every lap. Finally, smart control system must tie everything together, adjusting things in real time to keep the car fast, light and reliable.
Hello and greetings to all. My name is Amin. From my part, introduction to the basic calculations from this topic. The first equation is using a low speed turning Archimedes steering. Archimedes steering is geometrically linked the inner wheel to steer at a greater angle than the outer wheel. Based on the paragraph, it consists of two equations, which is outer steering angle and the inner steering angle. Theta 0 is outer steering angle and theta I is inner steering angle. For the theta O is equivalent to L over R plus T over 2, while theta I is equivalent to L over R minus T over 2. Theta is equivalent to steering angle. L represents its distance from the front to the rear tire. R is a turn center to the center of the vehicle, center of gravity of the vehicle, and T is a distance from the left tire to the right tire. This difference is calculated based on the vehicle wheelbase and the track width to ensure all wheel pivot around the common center, minimizing tire scrap during a low speed turn. That's it for me. For next questions, I choose a high speed turning, slip angle and the cornering stiffness. For the equation, Fy is equivalent to C alpha times alpha. The explanation based on the picture given, it shows the direction of viewpoint and direction of motion during turning, and the graph lateral force Fy against a slip angle alpha. For explanation, a higher speed, at the higher speed, the lateral force Fy that allows the car to turn is primarily generated by the tire slip angle alpha and their cornering stiffness C alpha. A larger split angle or a stiffer tire result is a greater cornering force. Okay, next for the calculations using a formula lateral force. The equation for the lateral force is a summation of Fy is equivalent to Fyf plus Fyr, or equivalent to mv square over r. Summation of Fy is a total lateral force, is equivalent to Fyf is a front tire lateral force plus Fyr is a rear tire lateral force, or is equivalent to simplified total vehicle lateral force, which is mv square over r. To maintain a steady turn, the total lateral force sum Fy produced by the front Fyf and the rear Fyr tire must balance the around internal force mv square over r, acting on the vehicle as it moves with mass and the velocity along the curve with the radius. That's it.
First of all, as you can see, the drawing of our topic, which is involve the front suspension and rear suspension. So in this topic, the parts that involve in which is the responsible for the cornering state are steering, suspension and tire, just like our sketches in the side of me. In order to sketch this design, we did some research about the steady state cornering. So by visualize the actual design and we draw physically. This is the final drawing of the front and rear suspension, as you can see in the side of me. So the parts in the front suspension, such as steering, rack pinion, coil spring, upper mounting plate and bearing and control arm. All those parts we included in the drawing. Also, for the rear suspension, we involve the shaker, axle housing and leaf spring. All the details as you can see in the our drawing.
The house of quality is a key in quality function deployment that helps translate customer needs into technical specification. It also aligns what customer wants with how to deliver it and using a matrix to show relationship. This method ensures product meets customer expectation and encourages collaboration across teams.